In the next video, we'll go on to Chapter 3, Section 5, where we're graphing linear equations in slope-intercept form. So in slope-intercept form, we need to obviously be able to identify the slope. We also need to be able to find the y-intercepts in order to or to graph, to identify the y-intercept and the slope and graph using these two. So first of all, we're simply going to find slopes. And when we have a graph, we can find a slope. We always move from left to right. And in this case, we're going to go down 3 and then right 5, which gives me a slope of negative 3 over 5. With number 6, we're going to go up 4, right 3, and so we have a slope of 4 over 3. Horizontal lines have slopes of 0. Vertical lines have undefined slope. There is no slope. Undefined, we say. We don't say no slope, but we say it's undefined. But a horizontal line has a slope of 0. Then with number 8, we're going to go down 4 and right 5, so we have a slope of m equals negative 4 over 5. All right, so in the first case, well, let's go back to number 7. One way you can perhaps remember that a horizontal line has a 0 slope is we did not go down at all or up. So the numerator is 0, but we went right 1, 2, 3, 4. So 0 over 4, which is 0. As long as the 0 is not in the denominator, you can, the slope will be 0. All right, we'll go on to the next set of problems. In these next two cases, we want to find the slope of a line from a table of values. And in order to find this slope, we need to find the differences between the x's and y's. Now remember that a slope is change in y. Rise, which is really the change in y over the change in x. Now in a table like we see in 9 and 10, the x's are on top and the y's are on the bottom. You have to remember that we have to do change in y over change in x. Now in order to do this, we're going to find differences. So for the x's, we go up by 4, up by 4, up by 4. And for the y's, we're going up by 2, up by 2, up by 2. So we know then that m is the change in y, which is positive 2, over the change in x, which is positive 4, or a slope of 1/2. All right, with the next problem, we're going up by 1 for the x's, up by 1, up by 1, and for the y's, we're going down instead from 2 to negative 5 is down by 7, negative 5 to negative 12, down by 7, negative 12 through to negative 19, again down by 7. So just remember that it's the change in y, negative 7 over positive 1, which gives us a slope of negative 7. So when you have tables of values, remember if they're horizontal tables and the y's are on the bottom, the change in y for the slope has to go onto the top. In the next set of problems, we want to be able to look at an equation that is in slope-intercept form, and make sure that we can identify what the slope and the y-intercept are. Remember the form is y equals mx plus b, where m is the slope, b is the y-intercept, and so we're just looking for in the slope, we're just looking for the number that's multiplied by x. So in the case of number 15, that would be 3. The y-intercept would be 2, or we can say that it is x is 0, y is 2. In number 16, slope is 4, y-intercept is -7, or we can say 0, comma, -7. In number 19, we can't answer the question just yet. We have to put this into slope-intercept form. We're going to do that by adding 2x on both sides here, and we get y is equal to 2x plus 4, so we can see that the slope is 2, the y-intercept is 4. Next, same thing with number 20. We can't automatically tell what the slope and y-intercept are. We have to solve for y, and we do that by subtracting x from both sides, and we get y is negative x minus 6, so the slope is -1 there. The y-intercept is -6, or we can say 0, comma, -6, and we'll go on from there. All right, so once we can look at an equation and identify what the slope and the y-intercept are, then we can graph those equations, first of all, by plotting the y-intercept, in this case, +7. Well, in this case, we can't, with number 25, we can't easily see y equals 7 on the graph. But what we can always do when that's a problem is we can make a small table of values. Remember, you can always make a table of values to graphing. This one is not that important to me. But when x is 4, for example, -4 plus 7 is going to give me a 3. So I would have this point, x is 4, y is 3. When x is 5, then y is going to be 2. And we can go back the other direction. When x is 3, plug that in, and you're going to get y is 4. And we can see what's happening here. And so the line is going to look like that. Eventually, it's going to pass through y equals 7, even though we can't see that on our graph here. I'm not too worried about that. How do we graph an equation in slope-intercept form? We first find the y-intercept. In the case of number 26, we find y equals 3. Then we use the slope to find additional points. We go up 1, right 2, up 1, right 2, and we can go down 1, left 2, down 1, left 2, and we can see where, how to graph this particular line, and we're all set. All right, so how do we graph an equation in slope-intercept form? We plot the y-intercept. Then we use the slope to find additional points, draw the line through the points. With number 29 and 30, we can't directly identify the slope and intercept, so we have to solve for y first. So if we had 3x plus y is equal to -1, we're going to subtract 3x on both sides, and that gives us y is equal to -3x minus 1. Now, we can start from the y-intercept, -1. Go down 3, right 1. We have no more room there, so we can go up 3, left 1, up 3, left 1, and we can see how this line falls. All right, number 30. Again, we don't have it in slope-intercept form, but we can put it there. We start with x plus 4y is equal to 8. Going to subtract x from both sides, and we have 4y is equal to -x plus 8. Then we divide everything by 4, divide by 4, and when we do, we get y as -1/4 x plus 2. So now we know that our y-intercept is 2. The slope is -1/4, so we're going to go down 1, right 4. No more room there. We can go up 1, left 4, and we can see what our line looks like. All right, so that does it for number 30. Okay, in the next two problems, which are related and are both going to be graphed onto these same set of coordinate axes, we have the function c of x is equal to 0.5x plus 70, represents the cost C in dollars of renting a truck from a moving company, where x is the number of miles you drive the truck. We want to graph the function and identify its domain and range. Remember that domain is a set of all possible x values. Range is a set of all possible y values. And so if in this case our variable x is going to represent the number of miles driven, and y is going to represent the cost, then we know that our domain, we just have to have x to be greater than 0. You can't drive negative miles. And your range, the set of all possible costs, well, the minimum cost is going to be $70. So y has to be greater than or equal to $70, and it will just go up from there. All right, so we're going to graph this function. We're going to start at 70, so I will label my axes, where each tick mark represents either 10 miles on the x-axis or $10 on the y-axis. So we're going to start from 70 with the first function. Start at 70, and it goes up 0.5 for every mile. But if you look at our scale is going up by 10, and so when x goes up by 10 miles, y will only go up by half or by 5 miles. So in order to go up by a full 10, we have to go up 20 miles. So that's going to look like a slope of 1/2. Remember, up 1, right 2, 0.5 meaning 1/2. And so we can get some more points in that same way. Up 1, right 2, up 1, right 2, etc., etc. All right, and we can draw a line there, something like that. All right, so that's interpret the slope and the c-intercept. Slope here, m, which is 0.5, is really the cost per mile. And the c-intercept, or um, the c-intercept, which is the cost where the graph crosses the y-axis, is at 70. That is the initial cost. All right, so let's go look at the next part of this. The next part of this is a linear function models the cost of renting a truck from a moving company. And here we're given a table of values. With the table of values, we have x is 0, y is 40. We have x is 50 and y is 80. And then we have x is 100 and y is 120. So if you look at this, you can see that this slope, or this line, is y goes up, or the cost goes up $40 when the mile goes up $50. And so we have a slope here of 50 over 40, which is 5 over 4, or which is 0.8. And so that means 0.8 is this particular function charges 80 cents per mile. And its y-intercept, or c-intercept here, c-intercept is the initial cost of $40 is the initial cost. And so we can compare. Again, it goes up by 4, and over 5. And so it probably is going to end up somewhere over here for the last point. Right? So if we were to draw that point, now what we can tell from this, now that we know about systems of equations, we can tell that the cost for the two companies will be the same when you drive 100 miles, and that cost would be $120. And that'll do it for this video.